We are on lesson 69. We are talking about direct variation. Your objective is right here. And we need to talk about what direct variation is, okay? Direct variation is defined by this equation right here. Okay, now you recognize y and x. We've been dealing with those a lot. This k, though, is called a constant multiplier, and you will see it called the constant of proportionality. Okay, so direct variation means that if I change one variable, so say I change x, that y always changes by the same amount. Okay, so for example, if your total pay is $12 per hour times the number of hours you worked, if I put in a 1 here for my number of hours worked, 12 times 1 is 1. If I put in a 2, 12 times 1 is 12. If I put in 2 hours work, 12 times 2 is 24. That's increasing $12 every time. So this is a constant increase. Okay, every single time. A constant multiplier is $12 per hour. Again, my total pay would be increasing $12 every hour I work. Same thing here. Another example is miles traveled. If I say I'm traveling 60 miles an hour, then my number of miles traveled will increase 60 miles every hour I travel. So if I travel 1 hour, it's 60 miles. If I travel 2 hours, it's another 60 miles, which is 120. And then if I travel 3 hours, that's another 60 miles. So the rate, okay, is the same every single time. That's this k number. Okay, it increases the same amount every single time that one of the variables changes. Okay, so let's go ahead and take a look at this a little more. Here we've got a couple characteristics of direct variation. It says when one variable is 0, so is the other. Okay, and then we want to look at the graph of the line. The graph has to intersect the origin. Okay, so if I'm going to make a graph for direct variation, it has to start at the origin. Okay, it can't start up here anywhere or down below the origin anywhere. Also, when one variable is 0, so is the other. So let's take that example of the money, okay, where you got total pay is the $12 per hour times the number of hours you work. Okay, if I work 0 hours, then I'm not going to make any money. Okay, so again, 0 hours would give me $0 for my total pay. So when one variable is 0, so is the other. Okay, again, I can't make any money if I don't work any hours for it to be direct variation. Alright, let's go on to some actual example problems now. Alright, for example 1, it says up here, which, you'll have to ignore this stuff down here for now. It says, which of the following is an example of direct variation? Okay, so it says a taxi company charges $3 to start the ride plus $2 per mile. Okay, so the number of dollars the taxi makes is going to equal $2 per mile plus the $3 to start the ride. Okay, $2 per mile plus $3 to start the ride. B says the area of a square is the square of the length of its side. So that just means that the area of a square is equal to its side times itself, or side squared. And C says the perimeter of a square is 4 times the length of its side. So perimeter of a square is 4 times each side. And we want to know which one is an example of direct variation. Remember, here's the setup here. Y equals k times x. Okay, so one variable equals a number times the other one. Well, if I look at the first one here, okay, this says dollars equals 2 times the miles plus 3. So I'm adding something on. Okay, so I'm multiplying and adding. So that cannot be direct variation. Okay, this one, I'm not multiplying necessarily, I'm squaring it. So I'm not taking it by the same number every single time. So this is not direct variation either. This one has the setup, okay? It says P equals 4 times S. Well, that looks like Y equals K times X if you look at them. Okay, where K is my number 4. That's the constant of variation. Okay, so that one is direct variation. Now, we could go ahead and make a table for these. So down here, we're showing you, here's the table for the first equation. So if I travel 1 mile, I get $5 because 2 times 1 mile is 2, plus the 3 to start the ride is $5. Then here, 2 times 2 miles is 4, plus 3 is 7, and so on. Okay? So when I look at the dollars for each mile, I'm looking at the constant ratio. Okay, I want to see if the ratio stays the same every time. So 5 over 1 and then 7 over 2. If this is direct variation, those should equal the same thing. Well, 5 over 1 is like 5, and 7 over 2 is like 3.5. Those are not the same thing. Okay, and then 9 over 3, $9 for 3 miles is 3. So the ratio does not stay the same. So this one is not direct variation, okay, because the ratios aren't the same. If I look at the next one, if I take area equals side squared, I plug in 1 for the side, well, 1 squared is 1. If I plug in 2 for the side, 2 squared is 4. And 3 for the side, 3 squared is 9, and so on. When I look at these, okay, the ratio of area to the side is 1 over 1. And then it's 4 over 2. And then it's 9 over 3. Well, 1 over 1 is not the same as 4 over 2. So, this one does not have a constant ratio, so it is not direct variation. And if I look at the last one here, my ratios are 4 to 1, and 8 to 2, and 12 to 3, okay, and all those are equal to 4 to 1 if I reduced them all. Okay, and 4 to 1. So this one right here is the direct variation because the ratio stays the same every time. It's increasing 4 times every single time. And let's go on to another example. Actually, sorry, looking at the same example, we can identify direct variation from a graph, okay? Remember that we said that graphs for direct variation have to intersect the origin. So this first one is out right away because it doesn't cross at 0, 0. Okay? Meaning, as soon as I hop in the taxi, I can travel nowhere and I still owe them $3. Okay? Now this down here says, a graph indicates a proportional relationship only if all the points are along a straight line that intersects the origin. Okay? So again, it has to be a straight line to be direct variation, and this one is, but doesn't intersect the origin. This one is not a straight line, okay? So it's not direct variation. And this one is a straight line and intersects the origin. So again, we could tell that from the graph that one is direct variation because it's a straight line that crosses the origin. And let's move on to the next slide. Okay, objective 2 up here is to determine the constant of proportionality. And here's our example. It says Doubleday doubled every number Eunice said. So Eunice is going to say a number and then Doubleday is going to double it. It says the table shows 4 numbers Eunice said over here and Doubleday's replies. We want to sketch a graph of all the numbers they could say, and we want to know, is the relationship of numbers they say an example of direct variation? Then we want to write an equation for the relationship, and then we want the constant of proportionality. Okay? So the very first thing we need to do is graph this. So I'm going to go ahead and make my y-axis and my x-axis, and we'll level them 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Again, when you make your graphs, I want them on graph paper, and I want them to be done with a ruler. Okay? So this says we need to make the numbers they say. So we'll pretend like Eunice is x, because she's the numbers that we're putting in, and Doubleday is our y's. Okay? So we're going to the point 2, 4, and we're going to put a dot there. Then we need to go to point 1, 2, and put a dot there. And then negative 1, negative 2, and put a dot there. And then negative 2 and negative 4, and put a dot there. Okay? If I sketch this line here, that's about what it should look like. Okay, so the first thing we want to know, is it an example of direct variation? Well, remember, direct variation has to be a graph that's in a straight line, which this one is, and it has to intersect the origin, and this one does. So, yes, it is direct variation. And we'll explain why even, because the graph is a line that intersects the origin. Okay, so that's one thing we need to say. Then we need to write an equation for the relationship. Okay, so I want to know, how do Eunice and Doubleday's numbers go together? Well, Doubleday's number is going to equal Eunice's somehow. Well, remember, it says he's going to double her number. So if I look, I'm taking Eunice's number times 2. And then times 2 here, times 2 here. So every time I'm taking Eunice's number times 2. So Doubleday's number is 2 times Eunice's number. And there's an equation. Okay, and again, if this is direct variation, this needs to follow the format, okay, that we've been given. So first thing is I'm going to box my answers here. That's 2 of them so far. My last equation, or my last question says, what is the constant of proportionality? Okay, well again, if I want the constant of proportionality, here's my equation I wrote, and it's got to follow this format: y equals kx, where k is the constant of proportionality. So it's right here, k equals 2. So that's the constant of proportionality. When I write the constant of proportionality, I always need to write k equals. Okay, k equals every time. So it's just the number here that's in the spot of k if we set up this kind of equation. Okay, where d and y match up, 2 and k match up, and e and x match up. Alright, let's go on to one last example. Okay, in example 3 says, Jared earns $12 an hour helping a painter. Create a table that shows his pay for 1, 2, 3, and 4 hours of work. Then we want to know, is Jared's pay for hours worked an example of direct variation, and if so, what is the constant of proportionality? Okay, so the very first thing that I need to do is figure out, how does Jared's money and the hours he worked go together? Well, Jared's money is going to equal his dollars per hour times the hours he works. Okay? Well, now I need to fill stuff in that I know. I don't know Jared's money at any given point in time, so I'm going to put a variable for that. His dollars per hour, it tells us right here, is 12. And we're going to multiply that times the hours he works, which I don't know. So times the hours. Okay? And now we're going to go ahead and create a table for this. Okay? Well, Jared's hours are kind of like our x's, because that's the number that we're putting in. And then his money he makes is like the y. So the hours are going to go in this spot over here. And Jared's money is going to go in the y spot. Okay, it says to make a table for 1, 2, 3, and 4 hours of work. So his money is going to equal 12 times 1, which is $12. And his money is going to equal 12 times 2, which is $24. And then his money is going to equal 12 times 3, which is $36 for 3 hours. And then for 4 hours, it's 12 times 4, which is $48. Okay, we need to figure out, is it an example of direct variation? So is the ratio of his hours, or his dollars to his hours, the same every time? Well, this first one is 12 over 1. Then we've got $24 for 2 hours, which is the same as 12 over 1. Then we got $36 for 3 hours, which is the same as 12 over 1. And then $48 for 4 hours, which is the same as 12 over 1. So this ratio is the same every single time. Okay? So yes, it's direct variation. And we want to know, what's the constant of proportionality? Okay, well, the constant of proportionality, again, is the number that it is increasing by every time. We are multiplying it by 12. Okay, so again, I can look at this. I can take my equation, J equals 12H, and underneath it write the Y equals K times X, and the constant of proportionality is always the K number. So K equals 12 in this case for the constant of proportionality. And that's your lesson on direct variation. Good luck on your homework.